Okay, so welcome back. Today in this tutorial we will start with tutorial part 2 chapter 1, which the questions are related to tree diagram and Bayes theorem. If I finish this earlier, then I can proceed with chapter 2. Okay, so chapter question 1 to 5 I have given the answer. You can see in the answers, the answer is here, but let me explain to you maybe question 1 and 2, 3, 4, 5 is almost the same thing. Okay, you can do it by yourself. Let me explain number 1 first. Draw tree diagram to compute all the joint probabilities for question 1 and 3. So I'll do number 1 first. Number 1.
Sir, we cannot see the screen.
Sorry. Can you guys see the screen now?
Can, sir.
Okay.
Yeah, Doctor.
The probability of A happen is 0.9. You can write here as A bar, or I write there as A complement. A complement is the other way around, not A. So A complement, this is the notation I'm using here. You can also use A bar, depends on you. So this is 0.1. So if the branches comes from one point, I told you this one plus this one is equal to 1. That's how you have to check. Here in this one, after A happen, the probability of, normally what we do here, okay, before this class, I write here A and AC, and I straight away write here B and BC, and this one also B and BC. Okay, this what happened. Normally what we write, we will write like this, but if you, there's another way of writing this, the same thing, same probability. How we will write? A happen first, and what is the probability of B? We can also write like this. So if you write this is 0.4. This one, A happen first. What is the probability of BC? It's the same thing, there's a notation different, that's all. AC happen first. What is the probability of B? And AC happen first. What is the probability of BC? This is 0.7. See, this is 0.4. this is 0.6 and this one 0.3. That's how you have to see. This is how you have to draw the tree diagram. And for us to compute the joint probability, what is the probability of BA? Joint probability means, see, all the joint probabilities. What we are going to find, first of all, what is the formula for this? This is the formula. So joint probability is this one. Okay, this is the joint probability. So how to find B and A? You multiply this. So when you multiply this, you will get B and A. What is the probability for PA? 0.9 times 0.4, that would be 0.6. And the same goes for the other. I told you, if you go by branch, what you have to do? Multiply PA multiply by this would give you the joint probability of BC A and A. This one is multiply with 0.6 0.54. Zero 0.1, 0.3 equal to 0.03. If I ask for joint probability, you have to find the combination of n. Okay, B. Once you find B and A, you no need to find A and B. It's the same thing. Okay, it's the same thing. So these are the answer for the joint probability. You can see the clear answer inside the answer script, the one I have given you. Okay. Same goes for number 2, and I suppose you can do number 2 same as number 1 and number 3 same as U1. So 1, 2, 3 done. You can try and see how it goes. Number 4. For number 4 also, I have given you the the tree diagram, but let me see number 4 what I can do here. I would like to go next page. Suppose there are 100 students in your accounting class, 10 are left-handed. So the probability of left-handed, I suppose you guys can do the probability, it's very easy. 10 out of 100. This will give you, I just leave it like this because later on there's something to do with this. And 2 students are selected at random. Draw the probability tree and insert the probability for each branch. The first student and second student. First student can be left-handed and right-handed. The probability of choosing a first student as left-handed is this one, and the probability of choosing right-handed is 90 over 100. The second student also can be left-handed and right-handed, left-handed and right-handed. Since we already choose one student out of 100, now the total is 99. Now, out of left-handed, we have choose, if see total left hand is 10 student. If you have already chosen one left hand, how much left? Somehow 9. If you want to choose the second left hand, is only 9 because the first left-handed you have chosen. Hope you understand. For right hand, the quantity remains same, which is 90. Now here you have chosen right-handed as a first student and you choose a left-hand as a second student. Left-handed untouched, so still 10 here, but right-handed will reduce by 1 because you have chosen the first student as a right hand, so it is 89 here. That's how we get the tree diagram. Of course here you can write L, no problem. Okay, you can write that. So here I'm just simplifying all the decision now, all the outcome. Here should be L and L. Here should be L and R. Here should be RL. Here is RR. Now this is the tree diagram. Draw a tree diagram and insert the probabilities of each branch. So this is a tree diagram. What they want in A, this is not A yet. Okay, I just write it here, A. Both are right-handed. Where is it? Both are right-handed. Is here. So take this one. This is actually see, if you go by branch, same branch, what you have to do? Multiply. If you do this, what you get? Zero 8 9 1. That's the answer I give. If B, both are left-handed, is here. I'm getting nine one. C, one is right-handed and the other is left-handed. One is right, the other one is left. One is left, right, this one right, left. So it is, the first one is, this one would be 10, 100 times, because I told you is from same branch. If the branch it follow the branch, means you have to multiply. So right here, and the other one is this one. Now this is one answer, this is one answer. If you jump from one branch to another branch, you have to plus. Now the answer you should get, let me double check. Even though I have the answer, each and every time I need to double check. You should get 0.1818, and D at least one right hand. At least one right hand. At least one right hand means it can go up to two right hand. So this one have one, this one have one, and this one have two. At least one right hand means it can go up to two. So if you do the same method as how we did, okay, you will get 0.9909. Okay, find each branch probability, and then you plus, you will get 0.9909. I just don't want to waste my time here. So this is question number 4. Anybody ask any question? I didn't open the chat. Okay, so far nothing. No screen set. Okay, all is done. All right. So this is regarding number 4. Number 5 is I want you to do same with Q4. Okay. Now what? Suppose that 3 people are selected. The same thing, but now 3. You can try slowly at home and try the question. Number 6. Number 6 onwards, I just give you the. Let me see what I can do. Number 6. Please have a read. Number 6. Please read the question first. The company president believes that there is a okay, first of all, hope you guys can read. On 2 separate federal government defense contract, so there's a 2 the company president believes that 40% probability. 40% means you right now you should be able to convert that into decimals. That should be 0.4. Winning the first contract. This is the first contract. This is the second contract. This is win. This is losing the contract. This is win. This is you lost. This is win. This is loss. Winning the first contract would be 0.4. And losing the first contract, as you, I suppose you are aware of to find this figure here, 0.6. If they win the first contract, the probability of winning the second is 0.7. And what would be here? 0.3. However, if they lost the first contract, if they lose the first contract, the president think that the probability of winning the second contract decreased to 50. So here winning the second is 0.5. This one is 0.5. What is the probability that they win both contracts? Win both contracts, this one, that would be 0.4 multiply 0.7, 0.28. Let me know if I'm going fast. I can slow down. What is the probability that they lose both contracts? 30. And what is the probability that they win only one contract? Winning only one contract, win, lose. Lose, win. You should get 0.42. Hope you guys understand this. Number 7. Maybe number 7 I can do also. A foreman of an injection molding firm admits that 10% of his shift he forgets to shut off the injection machine on his line. This caused the machine to overheat, increasing the probability defecting molding, increasing the probability from 2% to 20% that the defective molding will be produced. Okay, let's say F is he forgets, F bar he doesn't forget. This is defective, this is no defective, no defect, this is defect, no defect. What is the probability that he will forget? 0.1. He don't forget, 0.9. If he forgets to shut off the injection machine, this caused the machine to overheat, increasing the probability from 0. This caused the machine to do defective molding 20%. If this caused the machine overheat, increasing the probability 2% to 20%, which means if he forgets to shut off the injection machine, the probability of the machine producing defect products will increase to 20. If he don't forget, okay, he shut off the injection machine as how it should be. If you don't forget, the probability the machine will produce defective product is 2. So by normal day, the probability is 2 for the machine to produce defective product. Normal day means he shut off the machine as normal. If he forgets, what happened? 20. Okay, so now he forgets, and what is the probability of defective product? 0.2. He don't forget, what is the probability of defective product? 0.02. You can fill up here, you can fill up here. What is the proportion, probability, percentage, all the same method but different kind of writing style, that's all. What is the proportion of molding from the early morning run is defective? So we are going for defective. Start from this branch. How much is this? Am I right? Oh, 16, sorry. Oh, no, 9, 0.9 times 0.02. Yeah, I'm right. Jump from one thing you plus, so the answer should be probability of defective is 0.02 plus 0.018. That should be, what is the answer anyway? 0.038. Number 8, please do on your own. Number 8, you can do something same with number 8. I can write here. Do it yourself. Is something similar to normal tree diagram. Number 7, maybe you can do it yourself. Number 9, number 9, I can show you something here. So basically what they do, they're going to find, if you read the question, they're going to calculate diversity index. So what is diversity index is actually probability of different race. Okay, diversity index here is actually the probability of different race. They choose two people. So the first person can be white, black, or Asian. The probability for you to choose white is 0.8. This is 0.05. The probability for you to choose a second person for white, 0.8. Zero point 1.5, 0. It is white, black, Asian. We want the diversity index, we only want different race. So we will go to white, brown, white, Asian. We cannot go white and white because it's the same race. We compute all these things. If you compute this would be 0. This one would be 0.8, 0.05. These are the thing. If you plus all these things, you plus your answer should be 0.335. Okay. I give you some time to have a look at it. Number 10. It's quite complicated. Please have a read. Number 10. So if you read question 10, in one particular year, altogether how many candidates? 3000 candidates take level 1 exam, 2500 level 2, 2000 level 3. So the candidates who sit for that one particular year, total is this is total candidate. The probability a person sit for level 1 exam is 205. The probability a person sit for level 2 exam is 3, and the probability a person sit for third exam is 4/50. A person sit for first exam and he pass. What is the probability? 0.57. A person who sit for second exam pass. Now you know what is the value, 0.73. A person sit for third exam and he pass. So what is the question? The question is, what is the probability that he or she pass? So what is the probability pass? I told you before, if you want the probability of single item, single criteria, you need to plus all the related probability with that criteria. So pass and 1, don't have enough space here. I suppose right now you guys know how to find this, or you want me to show you? You know how to find this particular thing? Remember, we have done many exercises. It comes from here. So if you want to find this, if you want to find this, you multiply with this. That's how you find the thing. So if I want to expand this, that would be plus so if you do this, you will get here 2 if you do this, your answer should be 0.68698. So this is how you find the answer for 10. Anybody ask any question? Nope. Okay. So are you guys done with number 10? Can I move on to Number 11. Okay.
Yeah, okay.
Okay. So I go on with number 11. I show you number 11. Number 12 you guys do on your own based on number 11. So number 11, refer to question 1, determine PAB. If I want to find this, question 11 is easy. Okay, I just want you to show something here. This is A and B. So if I go back to question 1 here, thing is, in the question 1, from Q1 we are able to find P, B and A. P, B and A, what was the answer? P, B and A. Now you're getting the answer. Yeah, this is the answer. So number 12 is almost same with, I write here refer to Q11, number 12. Number 13, refer to question 7. The plant manager randomly select a molding in question 13. Question 13, the plant manager discovered a randomly selected molding is defective. What is the probability that the foreman forgot to shut off the machine the previous night? It is defective and it is the foreman forgot to shut off. So this is question 7. So from the question 7, you can notice that from question 7, if we go back to question 7 here, to your answer just now, from the tree diagram just now, if you want to find this would be how I draw the question 7. Let me check. Okay, I told you before, if you want to, you can write this as okay, you can write this as F, given F and D. So go back to the here, D and F is actually this one, and PF is 0.1, PDF is 0.2. so this is basically, this is your this is your answer, actually 0.02. so 0.1, 0.2. you will get 0.02. then just I want to double check. Yeah, D and F 0.02. is defective. The probability of defective, that was the answer. Probability of defective is this one plus this one, 0.038. This is we are getting from Q7. This is the answer. Question 14, I leave it to you. Question 14, refer to question 12 or something similar to that. Try to do, the method are same. Question 14, I'll leave it to you. Question 15, I can do question 15. What are Y, B and A is 0.24. Yeah, I changed already. This is the for previous question, isn't it? Yeah, it's 0.36. Sorry, I just saw your question. Let me know once you guys done. Can I move on to question 15 or not? Any of you still need time? Okay.
Should be done, Doctor.
Okay. So I'm going to question 15 now. Three airlines serve a small town in Ohio. Airline A has 50% of all the scheduled flight. B has 0.3. C has 0.2. Their on-time rates are 80, 65 respectively. So the planes are on time. If the plane is A and it is on time, I just put T here, is 0.8. This on time is a plane has just left on time. What is the probability that it was airline A? So the question is, the plane has just left on time. What is the probability of? This is the question. So basically we need to find probability of A and T and PT. For you to find this kind of question we have done previously in the Bayes theorem. For you to find this, you need to have this one, but since this probability you don't have, in fact that is the question anyway. This I have gone through this kind of argument, this kind of explanation in the previous tutorial. In case if you find the video, you can see this. So what we do, let me write this down here so that I have some space to write. So you change this to T and A, and T and A you can get it from TA multiply, you can get this. Okay, so I can write here PA and T is actually PA times this one. Okay, let me write in green color so that alright. And similarly we can also do this. We want to find probability of single criteria plus all the related criteria with that single criteria, which is T and A plus T and B plus T and C. This one would be PA, P and TA, PB, TC. So if you do this, this is what you have to write here. If you substitute all the values Okay, all the values here. Your answer should be 0.593. Please double check. Compute this and let me know whether you get the same answer or not. Do you get the same answer? Please compute. Any one of you? Alright, that is good. Some of you are getting. Okay. Yeah, appreciate that some of you are doing this. Yeah, I mean, all of you have done this. At least some of you share your answer with me. That is good. Okay, now what else? This is question 15. I move on to question 16. Yeah. See whether question 16, do I need to do that? What is this? Question 16. Question 16. So the company considering a new model of television. In the past, 40% of the television produced by the company have been successful and have been unsuccessful. Success rate is 0.4, unsuccess rate is 0.6. Before introducing the television to the marketplace, television to the market, the marketing research department always conduct an extensive research on favorable, unfavorable reports. In the past, 80 percentage of the successful television has received a favorable report. So this is 0.8, this is 0.2, and has received and 30 percentage of the unsuccessful television, and 30 percentage for unsuccessful television, this is 0.7. Okay, so if the television is successful, the report is favorable, which means the report is positive, people like the television, is 0.8. If the television is successful, people don't like the television, is 0.2. If the television is unsuccessful, 0.6. people like the television, 0.3, and don't like 0.7. That's how you have to read the thing. For the, by the way, what is the question? For the new model of television under consideration, the marketing research department has issued a favorable report. So question is, it is favorable, what is the probability that television will be successful? This is the question. Okay, this part I told you, you can write it as like this. rewriting the formula. You should get 0.64. Yeah, you should get 0.64. Anybody ask me any question? No. Anybody get answer for this? Okay, good. So 0.64. Good. Just give me a moment, I'll just go through the question. All right. So for question 17 to 20, you guys try do it yourself. Try first. It's quite easy. You can try. It's almost similar to the previous question. You guys try. If you cannot get the answer, then you can ask me, or you can always ask me. But you guys try first. Okay. So with that, we finish our tutorial of chapter 1. Now, as I told you, we still have half an hour to go. I would like to go through my chapter 2 to finish certain things. So maybe I give you 5 minutes, 5-minute rest. Is it okay? 5 minutes? You guys want to drink some water, or you want to go for washroom? I'll give you 5 minutes. Okay, not 5 minutes. I'll start at 12:40. Now 12:32, according to my timing here. 12:32. I start at 12:40. Take some rest, and we will continue with chapter 2. Okay, let us start. We stop here. Where is it? Yeah, we stop at this exercise in class 2. I give you the answer. Now we are going to find, normally if I give you some data 1, 2, 3, 4, 5, if I ask you to find the mean, variance and standard deviation, you can do with this data. What you do, you plus everything, divide by 5, something like that. We can also find mean, variance and standard deviation if you are given the probability of getting 1, the probability of getting 2, 3, 4. If you have any information regarding the probability, you also can find mean, variance and standard deviation of the particular data. Here mean, we will denote it by Ex, known for expected value. Expected value is the mean. VAR is variance, STD is standard deviation. Whatever we are finding this measurement here is for DRV. DRV is discrete random variable. Later on, for continuous random variable, we also will do the same thing, but different method, different kind of computation. Okay. Now let us focus on this example. The first example is, this is your first example, but I will do this later. Now I want to concentrate on this example first. Okay, the second example. So I write here example 2 first. Later on I will do example 1. Now the probability distribution function P, this is a probability distribution function, a normal one, the normal one of a discrete random variable is given this. Calculate the value of K. So what for us to find A, told you the summation of all the variables is 1. So what you do, for x equal to 2, 4, 6, all the values are K. Of course you can do the table first and then write, but I am doing straight away. Hope you guys understand this. Plus, if you put x equal to 1 there, you will get 2k. If you replace x equal to 3, you will get 6k. If you replace 5, you will get 10k equal to 1. So altogether how many k are there? 21k. So k is 1 over 21. That is question A. So you can rewrite again. Before we go on for B, I'm going to rewrite again this one. K is 2, 4, 6 and 2 over 21x. X is 1, 3, 5 and 0 is otherwise. if I write in table now, start from 1, 2, 3, 4, 5, 6. This is 2/21. This is 1/21. 6/21. 10/21 and 1/21. This is the table form if you convert that. Now B, we're going to find expected value. The formula for expected value you can see here. The formula for expected value is EX. EX is actually mean. This is actually mean. We are finding mean. This is XP multiply the variable with the corresponding probability. So how am I going to do this? Take your X times with this. Plus take 2 times with this. And so on. Do the same similar way method for other. If you do this, your answer should be 8/21, or you can write it as 3.90. This is how you find mean for a given question. Okay, you guys copied already? Can I move on? right? Let me finish this example. Next is C. C is x greater than this one. X greater than 3.9, which is for 5, 6. Just now we go until 6, isn't it? Yeah, 6. So this one would be 1 over 2, 1 over 21. Ten over 21. Number 6 is 1 over 21. If you do this, you will get 12 over 21, 4 over 7. For variance, the formula for variance is minus this one. Okay, this is mean. We already found what is the mean. We need to find this one now. This is a table. For us to find x square, ex square is the same thing, but you have to square it here. if you do this, you will get 36221, and your variance you can find variance is which is 1.99. That would be the answer. So we have done example 2. Example 1 I will do in the next class. Okay, example 1 I will give you, because example 1 there's something I need to highlight. Let me know once you guys done. We are almost finishing. There's one last part. I will give you the answer. You go back and try. Okay, some are done. Okay, so I'll go to next page. For example 3 here, for example 3 here, I give you the answer. For A, this one I teach you just now, you should get 3, and this one you should get 10.4. Variance also I teach you just now, 1.4. For C, variance of 3x, I'll tell you what to do. Let me write the answer first. Exercise in class 1. These are the answers. Okay, in example 3, if you see here, there is variance, question C here, there is variance 3x minus 5, variance 3, negative 3x plus 2, and here in exercise class 1, expected value of 2x minus 9, variance 3x plus 10. All these things, please refer to these 2 slides. Okay, you can see I have given here notes and I give you an example here. Same thing, I have given here the note and I have given example here. You refer to these two slides and try to do these exercises. If you cannot get the answer, you can either ask me in the next class or you can ask me by sending the question. Okay. So with this, let us finish the tutorial for today. For discrete random variable, there is left one example only, this one. I will teach this in next class. After that, I will go for the second part, which is continuous random variable, and try to finish the chapter. With this, that's all for today. Thank you very much for joining the class. I'll see you guys next week. Take care and stay safe. Bye bye.
Thank you, Doctor.
Thank you, Doctor.
Thank you, Doctor.
Thank you, Doctor.
Thank you, Doctor.